Hi, let me welcome you to this first of several videos we're going to call The Basics. We're going to show you how to fill the gap in on the basic class you took on the programmable controllers and move to a more advanced controller technique. Now I want to start off with a fan coil that you've seen before, and I want to show you a couple things with this fan coil. I want to maximize just the top application part and talk a little bit about it, because one thing that you probably are aware of is that there's many pieces to this puzzle. We have the zone temperature, which is connected to the occupancy mode determination. The zone temperature set point is also connected to the occupancy mode determination. But the zone temperature is connected to several other things, such as the occupied zone sequencing, the proportional heating and cooling control. In fact, it's even connected to the occupancy status determination. We could go ahead and look at this in a little bit more detail, and one of the ways you can look at it is by saying something like show involvement. I could go to the cooling output and show involvement, and that would allow me to see all the modules that are involved in controlling that output. And if I change, let's do the heating instead, you could see that. Or the supply fan control. So you see a little bit of different sequence every time. We found out that some of you are having a bit of trouble connecting between what you built when you built these standard modules in the basic class and how to get from here to being able to build and adjust custom modules. We're going to do what you probably shouldn't do in the field, and that's build a system from scratch. And we don't build the systems from scratch because, number one, we've got a really good programming tool to get us most of the way here in Controller Tool, and it costs way too much money to be able to build things from scratch. So we're just going to do it just this one time. We're going to kind of almost rebuild this same fan coil as we go through this systems. Let's have a final look through the system. You're able to look through the different parts of the system. You can see there the different inputs that are part of this, some of the different modules that you'll find there in set point miscellaneous and state generation, output control, and then all the way to the outputs. As I go back and show the parameter screen, you'll be able to see the different parameters that they have built, as well as the various connections. We'll be able to see the state tables that are built and even the exposed BACnet objects in our system. But before we go on and build this thing, I want to go ahead and save this so that a little bit later we can come back and compare it. So I'm going to choose File and Save. And I'll just save it to my desktop as fan coil. And then, as I said, we're going to do something that you normally wouldn't do, and that's build it from scratch. So to do that, I'm going to click File and then New. I'm going to call this Custom Fan, and instead of a system type like fan coil or air handler, I'm going to choose Custom Applications. No system configuration here, so I'll say OK. Now when I do this, the first thing I do is I get this mechanical system wizard that allows me to add certain inputs, certain outputs if I want to. And there's plenty of outputs I could add here. If I wanted to, I could build them in this location as we kind of go through and see the list. But in my particular case, the only thing I'm going to add are zone temperature. And what I would like to do is show you how to add multiple zone temperatures. In fact, we'll be adding even another one later, but I'm going to add 2 sensors in this one. Now I could add other sensors and other things as well. As a matter of fact, if we look down on the list a little bit, we'll even see that we have the ability to add, various miscellaneous status items and everything, but we'll get to those a little bit later. We'll just choose Next, and then in our outputs, we have the choices to add outputs, and I know I'm going to be adding a fan output, so we'll go up to Command Motor, and we'll choose one of those, and we'll just do one and do its status. Now again, we could add other ones, and you can see there's plenty of objects down there below that we might add. For example, voltage output. Maybe I was going to add a valve. I could do that right here if I wanted to. But I'll leave that for in the module, and we'll build it in the system. So let's go ahead and click Finish. One thing to know before we do click Finish, if I hit F1 in here, I would see a little bit of help over to my right. So the help is kind of built into this module. And as I click on different things, for example, if I went and clicked on miscellaneous output again, I'll see this specific help for whatever I'm clicked on, so which works out pretty nice. I'll finally click Finish, and now it's going to build my system as it is. As you can see, it hasn't built much for me, just a couple of inputs and a couple of outputs. The first thing I'm going to go ahead and do is rename my miscellaneous my motor output and my motor status there. I'm not sure where that miscellaneous 1C came from. I didn't remember adding that one, but it's possible I did by accident. So I'm going to rename motor C. I'm going to rename this SF-S. And I'm going to do the same thing with motor 1C, SF-C. This miscellaneous 1C, I'm not sure where that really came from, so I'm just going to go ahead and delete it. Now I'm kind of ready. Again, I'm going to go ahead and maximize the top screen here for the moment. And I'm going to decide that what I want to do is build a strategy. And here's the strategy I'm going to build, at least initially. If the average zone temperature is greater than the set point, then turn the fan on. So that's going to be my initial strategy that I'm going to build. If I'm going to do that, the first thing I'm going to need to do is have a set point. Don't have a set point just yet, so I want to build one, and I'm going to build that as a network input. So in order to do that, I'm going to right mouse on the network inputs, choose new, and I could filter a little bit, but there's really not a whole lot to filter right now. I'm going to choose one of my input floats and add one to there. And I can name it right here, and I'm going to call it ZN-SP. I could have just left it miscellaneous and renamed it in the system, but this is as good a place as any. And you'll notice it added it to the system. Now, I don't want it to start, when I first start the system, I don't want it to start at 0. I want it to start at kind of a fixed or an existing or default value. So I'm going to right mouse, view its details, and change its initial value from 0 to 72. That's going to be my zone temperature set point. I'm going to go ahead and do an average block. I need to average my zone temperatures together. And so I could just build an average function. Average functions are pretty easy. All I really need to do is add the two zone temperatures together and then divide them by 2. But there's also existing average modules. I could build a brand new module, add the average block to it, and build it that way. But here's what I do know. I know there's a module that already is built to do average. If I want to be able to find that, I can hit F1 and help will tell me how to find that module. Controller Tool has extensive help, and F1 accesses that help. Controller Tool help comes in one of 2 ways, either a Windows help file or a PDF help file. I've decided to open the Windows one, and I'm going to go to search and search for average. I could even search more extensively than this. But as you can see, I have a pretty good little list, and I happen to know that I'm looking for modules, and they're usually down at the bottom, and the one I'm looking for is called Side Loop Average Input. Let's see what it says it does. This module averages the inputs to produce the output. The module accepts 2 inputs and outputs the average of the inputs. The user can add more inputs to the module. This appears to be what I want. So now I'm going to close Help, go back to Controller Tool, right mouse on Setpoint Miscellaneous, and add a new module. So there's a filter here, and this really makes it easy because I'm just going to filter by putting side loop. And it shows me down, there's my side loop average input. I'm going to add one there, but I don't want it to be side loop average input. I want to call it zone average input. So I changed that, and I'm going to finish. Now I could just go ahead and start connecting, but let's go ahead and go into zone average input and take a look at the logic. But to do that, we're going to right mouse and choose View Logic, and we'll see it's there. There's my inputs, there's my outputs. I want you to notice that the output, present value called right now, is black. That's because it is the default element, and it's what's going to display up in the control view in commissioning or in simulation. This average input currently has 2 inputs, but it's real easy to add a third one if I wanted to. I could either grab a activity input float and drag it in here, rename it of course, or I could, after I delete this one, just duplicate the existing input by either hitting Control D or by right mousing and choosing duplicate. I'll just rename this. If I want to add this to the module, I have to double click on the module and choose I/O additions or deletions, add an input, and again I'm going to call this input number 3. I'll now close the module, and you see the new input, and now I'll connect it. Pretty easy to add it there. I now have to go back out to the control view and add another input here. Well, again, it would have been easier if I'd added it back in the system select tree, but I'm going to add it here by again right mousing, choosing new, again filter. I'm going to go with zone and temperature. So we see now that I have zone temperature. If I want, I could even pick zone 2, zone 3 temperature, but here's one. And I can pick my signal that I might want. For example, maybe I want to go ahead and go with nickel RTD, and I can call this zone 3 temperature like that. And I'll finish. And now it's a matter of connecting these guys to the zone average input that I've already built. Now you'll notice the zone average input has a green triangle in front of it, letting me know that I've made some change to the logic so it does no longer matches the standard module. So let's do a connection. Now I have to view my feature screen, and under feature screen I'm going to click on connections and then click on the module I want to connect to, which in this case is the zone average input screen. It shows my 3 inputs, and so I'm going to start to connect them. Make connections, and I'm going to start to pick the 3. So zone 1 is the first one, zone 2 will be the second one, and finally zone 3 for the third one. Now you'll notice I'm choosing O1 and not priority. O1 or output 1 is the output of that particular module. The priority is going to be its command priority, which is typically 16 at the BACnet level. It could of course be commanded to a higher level. And now I've made that connection. Now eventually we're going to connect the present value out to something else, but not just yet. So let's go ahead and save this custom fan to my desktop, and let's try a quick simulation and see how this works out. And we'll simulate, at least for the start, at 5 times speed, and we'll leave all our values initially the same. This debugging thing that you see here allows me to set up some traps inside the programming so that when I reach a certain condition, the simulation will temporarily pause so that I'm able to do some troubleshooting. We'll do that a little bit later in the steps. So now if you'll notice, because my 3 temperatures are all 72, I'm going to go ahead and have a value of 72 there. Let's use simulation to change one of my temperatures. We'll change number 3 to 74 instead of 72. And we ought to have an output of 72.7 now. It looks like our average is working. Again, the reason we're seeing that 72.7 is because our default value has been defined within our program. Well, that's it for now. Of course, we aren't doing anything with this thing yet. All we did was calculate the 72.7. In our next video, what we're going to do is take that 72.7, and when it reaches that set point value above that set point value, then we're going to go ahead and turn on our unit. But we haven't done that quite yet. We'll get to that in our next video. Thanks.